All right, here we go with the second part of our lesson on Module 2, Lesson 1, Greatest Common Factor. Today we're going to focus on this part about the distributive property. So we stopped last time because I want you to have the graph paper and I want to be able to take the time to go over it and not try to rush. So here we go with that second piece. All right, so if you go into your notes in Module 2, Lesson 1 to this page that we had skipped previously, we're going to look at these area models. So here you have all these area models, and it's 5 by 9 and 3 by 15 and 1 by 45. Well, if you look at this, 45 is the largest number, and when you multiply it by 1, it gets itself. So to find what's going on here, so anytime you have a side length of 1, whatever that other number is, that's the number that you're factoring. That's your biggest factor. So in this case, all of these numbers here, so 9, 5, 15, 3, 1, and 45, these are all factors of 45. So what we did was we took 45 and we broke it into different area models. We said, okay, well, we can make a rectangle that's 5 by 9, 3 by 15, or 1 by 45. And again, each of these numbers has to be a factor of 45 in order for that to work. Okay, if it wasn't a factor of 45, we wouldn't be able to select 2. We wouldn't be able to draw it 2 by something because 2 is not a factor of 45. So now what we're going to do is you have your own piece of graph paper, all right? And if you don't have one, please make sure to grab one. And we are going to work on B, C, and D all on that. Well, we're going to do B on the graph paper, and then we're going to answer C and D while looking at that graph paper. Okay, so first it asked us to draw all the different area models that we can for 60. So to start off, I'm going to say, okay, I can do 1 by 60. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so I know here my page is getting too small. So what I'm going to do is I'm going to say that each one of these represents 10 for mine. For you, please draw 1 by 60. All right, unfortunately my screen will not allow me to do that, so you need to make sure that yours is 1 by 60. Okay, so then now, since I know 60 is divisible by 2 because it ends in a 0, I could do 2 by 30. Fortunately, I already counted that all of these are 30. So 2 by 30. I know 60 is divisible by 3, so I could do 1, 2, 3 by 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So again, 3 by 20. I know 60 is divisible by 4. So 1, 2, 3, 4. And that'll be 15. So if this is 20, 19, 18, 17, 16, 15. So again, 4 by 15. Excuse me. Okay, and then I also know that it is divisible by 5, and it's 5 by 12. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I also know that it is divisible by 6. Let me see if we can get this. There we go. So it has to be 6 by 10. So I'm actually going to copy my page here because I'm running out of space. All right, so don't erase any of your stuff. I have to erase mine so that way I have the room to do it. There we go. So now I know I can do 6 by 10. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, is it divisible by 7? No. Is it divisible by 8? No. Is it divisible by 9? No. And now we're all the way back to 10. So in this case, I had 1 by 60. I had 2 by 30. Now these are, we're not saying, the X here represents the word by, so these are dimensions. 3 by 20. 4 by 15. 5 by 12. 6 by 10. So here are all the different dimensions that we made. Again, all of these are factors of 60. Okay, so in this case, if we look at this, which ones did they have in common? So 45 had 1 by 45. It had 3 by 15 and 5 by 9. So if we look here for the ones that they had in common, it was 1, 3, 5, and 15. So 1, 3, 5, and 15. Okay, what do these numbers all represent? These are all common factors of 60 and 45. Okay, so each of these is a common factor of 60 and 45, and we just use them, we just use area models. It's another way of trying to find common factors. So we use the area models to help us find that. Okay, now what's the greatest common side length? Well, 15 was the biggest common side length for both of them, and that would then represent the greatest common factor. All right, so in this case, we use the area models to help us find the different factors. Okay, and again, factors are whole numbers that can divide another number without getting a remainder. Okay, so that's why you don't see any decimals or fractions on here. So these are all numbers that can evenly or nicely divide 60 and 45. And then 1, 3, 5, and 15 are the ones that they have in common, with 15 being the largest. So far, this is all the same idea. Right, so here are your answers for A, B, C, and D. Okay, so now what we're going to do is we're going to take 45 and we're going to write it as a product of the GCF and another number. Well, we did that here because we said the GCF was 15, and here we know that 45 is the same thing as saying 3 times 15. Okay, well, then we're going to do the same thing with 60. We know that saying 4 times 15 is the same thing as 60. Okay, so now what we're going to do is we're saying that if we took 45 plus 60, that would be the same thing, and I'm actually going to write mine in colors, so fill this out the way that you would, but I'm going to fill mine out in colors so you can kind of see what we're doing here. We're saying if we did 45 plus 60, that would be the same thing as saying, so if we add our two products, it would be the same thing as adding our two multiplication problems. So the same thing as adding 3 times 15 plus 4 times 15. So adding our products is the same thing as adding our multiplication problems. So 60 plus 45 should give me the same thing as I would get if I did 3 times 15 plus 4 times 15. Which, if you think about it, just looking at it, 3 times 15 gives you 45, plus 4 times 15 gives you 60. So once you start working on the problem, you'll notice you get the same thing. Just so you understand that these two things are equal. But that's not what we're working on. We're working on using the distributive property. So now to use the distributive property, what we're saying here is if we take the 15 and pull it out, we can say that 15 times 3 plus 15 times 4 is the same thing as taking the 15 out and putting the 3 plus 4 in parentheses. So we're saying that this part here is the same thing as writing 15 times 7. Now, I know this seems silly and it's a crazy way to do some math, but it's lending itself to help you with algebra, okay? So I know it's confusing. Please don't expect yourself to be able to do this right off the bat. We're going to continue practicing with it. Again, this is just your introduction lesson. So let's take a look at the reflection problems. So you have 27 plus 18. The first thing that you want to do is you want to find the GCF. Okay, and in an effort to save us some time, I'm just going to tell you the GCF in this case. So the GCF for these two is 9. Okay, and I know that if I take 27, it's the same thing as saying 9 times 3. And 18 is the same thing as saying 9 times 2. So what I can do is I can say 27 plus 18 is the same thing as 9 times 3 plus 9 times 2. Then I can say 27 plus 18 is the same thing as 9 times 3 plus 2. So then I can also say that 27 plus 18 is the same thing as 9 times 5. Right? So I would strongly encourage you to grab a separate sheet of paper so you can continue to do these like this, because otherwise it's going to get really chaotic on that small little sheet. I honestly want to see all of this. Okay, so don't just try to slap an answer right up here. Give yourself space to show this work. All right, so again, I'm going to copy mine and I'm going to do the next one with you again. All right, copy this page. Clear it. All right, and then we're going to do number 7 together, and then you're going to try number 9 on your own and then come back and check your work. So for number 7, the greatest common factor here would be 12. Okay, so 120 plus 36 is the same thing as saying, well, 12 times 10 plus 12 times 3. So 120 plus 36 is the same thing as saying 12 times 10 plus 3, which is the same thing as saying 126 is the same thing as 12 times 13. Okay, I will tell you that for number 8, the GCF in this case is 1. So the greatest common factor of 9 and 35 is 1. So I want you to go ahead and take a minute and try to do this work on your own. And when you come back, we'll check your answer. All right, so in this case, yet again, we have 1 being the GCF. So 9 plus 35 is the same thing as saying 1 times 9 plus 1 times 35. So 9 plus 35 is the same thing as saying 1 times 9 plus 35. So 9 plus 35 is the same thing as saying 1 times 44. Okay, hopefully you got to that point and you're taking that time. I know it's hard. Just remember you're trying to take this and break it into a multiplication problem, break it into a multiplication problem, and then take that common factor and put it on the outside while taking your numbers and putting them on the inside and then adding them together. I promise you will get lots of practice with this. I do want you to go ahead and try the guided practice problems. So the guided practice problems in this case for you were the ones that were numbers 2 and 3 on your last sheet. So I do want you to try numbers 2 and 3 for when you come back to class tomorrow. As always, if you have questions, please be sure to write them down or email me so we can go over them in class.